Welcome to BIO216 again. Chemistry of carbohydrate, lipids, and nucleic acids. Last week we looked at carbohydrates as a whole, and we were able to note that there are three classes of carbohydrates: monosaccharides, oligosaccharides, and polysaccharides. In this video, we are going to concentrate on monosaccharides. At the end of this class, you should be able, among other things, to draw the glucose structure. So you are welcome again to about 216. We are looking at the topic monosaccharides, and we'll concentrate on glucose. So monosaccharides are a single consists of a single polyhydroxyaldehyde. If you remember when we defined carbohydrates, you met this term polyhydroxyaldehyde. You met this term polyhydroxyaldehyde or ketones. We said carbohydrates are polyhydroxyaldehydes or ketones, or substances that yield these upon hydrolysis. So the most abundant monosaccharide in nature excuse me, is the 6-carbon sugar D-glucose. You find it in starch combined together. You find it in cellulose. You find it in the sugar you use to drink tea. When I mean sugar you use to drink tea, I'm talking about the sucrose, which is also called table sugar. D-glucose is represented there. So it can also be referred to as dextrose. That's the most abundant monosaccharide in. At the end of the lesson, you should be able to draw the structure of glucose, explain the Fisher and Howard projection of glucose, discuss the cyclicization of the Fisher projection formula in monosaccharides. So let's start by drawing. So when we say monosaccharides, remember when we said they contain aldehydes. In our last class, I was trying to point it out to you, but I couldn't. So this is the aldehyde structure, and this is the ketone structure. So anytime you see a sugar molecule, look at it and determine whether it contains an aldehyde or a ketone. If it contains an aldehyde, that means it is just an alkyl group. The carbon will be attached to an alkyl group, and the other end will be a hydroxy group. Sorry, a hydrogen atom. Whereas if it's a ketone, you will have two alkyl groups attached to the carbonyl carbon. I want to believe you still remember what we mean by alkyl group. Check your chemistry in case you've forgotten. Learning is a continuous process. So the structure of glucose. Glucose can be represented either as a straight chain or a cyclic structure. That straight chain is what we call the Fisher projection, and the cyclic structure is called what we call the Howard projection. Both of them are still glucose. So how did we come about the name Fisher projection? This Fisher projection was devised by a German chemist known as Emil Fischer. He did this in 1891, and because of that he won a Nobel Prize in 1902. In the Fisher projection, carbohydrate is shown as open chain. It's shown in its open chain. And what do we mean by this open chain? Just contains carbon atoms in the main chain connected vertically, while the hydrogen atoms and hydroxyl groups are bounded horizontally. Remember we said that glucose contains C6. The formula of glucose is C6, H12, and O6. So these 6 carbon atoms are bound together. Then you have hydrogen atoms and hydroxyl atoms bond and joining them to form the glucose. So let's see how to draw this glucose. The first thing we do is to draw the chain of carbon. You can see we have 6 carbon atoms joined together in a chain-like structure. And when we draw this for each carbon, you give it wings to fly. Let's call it wings to fly, because these wings are bonds that will contain the hydrogen atom we mentioned, hydrogen and hydroxy atom we mentioned. So for glucose, it has 4 carbon atoms on one side and one four carbon sorry, not carbon atom, forgive, 4 hydrogen atoms on one side, and then the other side 1 hydrogen atom. You can see 4 hydrogen atoms on one side and the other side 1 hydrogen atom. So once you draw the carbon atoms, the next thing you do is to fix the hydrogen atoms, and when you finish fixing the hydrogen atoms, the next step is to fill up the blank. Remember, we still have some blank places. So what do we put in those places? We put the hydroxyl groups. You can see that the glucose we are drawing is taking shape. And once we put those hydroxyl group, the next thing we'll remember to put is our aldehyde group. Remember to put our aldehyde group. You can see, remember in the aldehyde group we drew, we showed C attached to O in an alkyl group and the hydrogen atom. Remember, so this is our glucose. At the end of the chain, fill up the last carbon with a hydrogen to make it it totally bound. Then you put the alkyl group on the carbon number 1. I hope you heard the what I called it, carbon number 1. Carbon number 1 is the carbon that bears the aldehyde group. And once you do that, you have your glucose. You have your glucose structure. By the time you count, you find that our formula C6H12O6 is well represented, and that is the glucose formula in the Fisher projection. So the next thing we will do now is learn how to draw the Howard projection. But before then, let's have a class activity. Draw a straight chain glucose structure and number all the carbon atoms. I'll give you some time to draw that, bearing in mind all the things we have said. Good. So now compare what you have with what we have drawn before in the other slide. And let's move to the next type of structure, the structure, also named after another scientist. This one, an English chemist known as Sir Norman Howard. Sir Norman Howard. He tried to expand the work of Fisher. I hope you still remember that Fisher did his work in 1891. Good. So this one did his own much later, and he received his own Nobel Prize in 1937. I hope you remember when Fisher received his own, 1902. So in the Howard projection, glucose is represented in a cyclical form. The the carbons too, we have only 5 carbons in the we have only 5 carbon atoms in the structure. Carbon 1, 2, 3, 4, 5. The 6th carbon is attached to the 5th carbon on top. It is not part of the structure. Instead of having the 6th carbon as part of the structure, the oxygen of the OH group on carbon 5 attaches itself to the carbon 1 carbon to form this cycle. Now let's look further at the cyclicization of glucose. Glucose molecule can exist either in linear or cyclic form, but it quickly takes up the ring-like structure immediately it comes in contact with water. So this is what I was trying to tell you. You see, the carbon 1 combines itself with the O of the hydroxy on carbon 5 to form the cycle. You can see our carbon 1. Remember we said the OH groups on the right go down. You can see carbon 2. You see the OH group is now facing down, whereas the ones on the left face up. So you can see all the OH on the right face down and the ones on the left face up. So that's how we draw our cyclic carbon. Then the next thing you must note is that you must also take note of the positions of the carbon. The carbon 1 comes here, carbon 2, carbon 3, carbon 4, carbon 5, and then carbon 6. Then another thing we must note is what happens to carbon 5 and carbon 1. By the time carbon 1 becomes cyclicized, it forms a stereocenter. You find out that carbon 1 is the only carbon that has 2 oxygen atoms attached to it. The other carbons have 1 oxygen atom attached to them. You can see, this is our carbon 1. It is attached to this oxygen and also this oxygen. And because it is attached to 2 oxygen atoms, we have another type of isomerism playing out in this structure, in this cyclic structure. Remember we talked about isomerism in our last class. So we have another type of isomerism. When we mentioned the D isomer when the OH group furthest away from the carbon 1, or the you can see the carbon attached to aldehyde, is on the right, you say it is a D-glucose. When it's on the left, you say it is an L-glucose. Now, we now have another type of isomerism here. When the OH group attached to this carbon 1 is facing up, you say it is a beta isomer. This carbon 1 is called an anomeric carbon. It's called the anomeric carbon. And when the OH group attached to carbon 1 is facing down, you say it is an alpha isomer. So we have this alpha D glucose and alpha beta D glucose are now isomers known as anomers, because they have this anomeric carbon, the carbon that has two oxygen atoms attached to it. So now we have been able to, so by the time we form a D-glucose is converted to a cyclic, by the time a D straight chain glucose is converted to a cyclic glucose, it will either form an alpha D anomer or a beta D anomer. That brings us to another, you look at this name now, we have alpha D gluco, and there's another new word, pyranose. Pyranose is the name given to a structure or a sugar that is a six-sided structure. You can see 1, 2, 3, 4, 5, 6. So this is an alpha glucose because the OH on carbon 1 is facing down. D because it came from a D glucose, and then pyra because it is in a shape, it is a six-sided shape, then nose because it's a sugar. So we have alpha D glucopyranose. So if you see a name like this, it's just a big way of telling you that this is a cyclic glucose that came from the D isomer, but the anomer on the anomer carbon and the anomeric carbon, the OH group is facing downwards. Good. So, like I mentioned, pyranose. This monosaccharide has a six-membered ring that consists of 5 atoms and 1 oxygen. There are no double bonds. We have mentioned it. The ring in pyranose is formed due to the reaction of hydroxy OH on the 5th carbon C5 of glucose with the aldehyde group at carbon 1. We mentioned it too. Apart from pyranose, at times glucose can cyclicize to form a furanose. What happens to get a furanose? If instead of carbon 5, the glucose, if instead of carbon 5, the carbon 4 reacts with the carbon 1, that's instead of the carbon 4 of a glucose or a monosaccharide reacts with the aldehyde or ketose group, reacts with the carbon bearing the aldehyde or ketose group in carbon 1. Instead of having a 5-sided figure, instead of having a 6-sided figure, we'll have a 5-sided figure. And the name of such figures are furan. So we have furanose to tell you that we're still dealing with sugar. So let's take a break here and do class activity. Draw a structure of an alpha D glucopyranose. Alpha D glucopyranose. I hope you know how we came about this long name. So I'll give you some time to draw it. Good. Um, I want to believe that you have got it. Practice more on this structure of glucose. So what have we learned today? We have learned how to draw. We have learned that glucose can either be a straight chain or a cyclic form. And we have learned that the straight chain is called Fisher's projection, whereas the cyclic one is called Howard projection. And we have also learned that we can get the cyclic chain by from the straight chain by cyclicizing it to form pyranose or furanose rings.